Welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 1761. Calculate money in Leetcode bank. Okay. Hersey wants to save money for his first car. He puts money in Leetcode bank every day. He starts by putting $1 on Monday, the first day. Every day from Tuesday to Saturday, he will put $1 more than the day before. On every subsequent Monday, he will put $1 more than the previous Monday. Okay. Given here, return the total amount of money he will have in his Leetcode bank at the end of nth day. Okay. Let's take n is equal to 20. Okay. So when n is equal to 20, he has on the first Monday he will start at 1 rupee. On the next day he will keep a money which is 1 rupee greater than the previous day, which is 2 rupees, and on the third day he will keep 3 days. On the fourth day he will keep 1 rupee more than its previous day, which is 4 rupees, 5 rupees, 6 rupees, 7 rupees, and so on and so forth. Now that he has reached Sunday, now he has reached the Monday of the next week. Okay, whenever he reaches Monday, he will actually check what money he has kept in the previous Monday, and then he will add 1 rupee to it and he will start it. Okay, so on this Monday, on the first week of Monday, he will keep 2 rupees, and then he will keep 3 rupees on the Tuesday, which is 1 rupee greater than the day before, and so on and so forth. Okay, so let's try to understand. Let's see the pattern carefully. Okay, so there is one property that every day he will keep 1 rupee greater than its previous day. Correct? That is what has been given. So on day 1 he will keep a money which is greater than the day before. Ideally there is no day before. Let's assume that there is a day before, and let's say he has kept 0 rupees on the previous day. So he will keep 1 rupee over here, 2 rupees over here, 3, and so on and so forth. Okay, now he has to know what money he has to keep whenever he reaches the next Monday, right? After 7 days. Okay, after every 7 days he has to identify what money he has to start with. Okay, if you see here, he has started with, in order to start with 2, that means he on the day before he has to give 1 rupee. Assume that there is ideal one day. So in order to start with 2, he has to start with 1. Okay, so we have assumed that in the problem statement they have been given at every Monday he will give 1 rupee greater than its previous Monday, right? So there is one ideal day before. So okay, so ideal day will also start 1 rupee greater than its previous ideal day. So since we know that previously he has started at 0, now this has to start at 1, because 1 rupee greater than its previous. Okay, and the next start of the next week will be ideally 1 rupees greater than its previous day, right? So we will have a variable called start. Okay, and then every day, okay, what we'll do, we'll start this week, will start with money equal to this start, and then every day we will add 1 rupee extra to our total. Okay, and once we exceed 7 days, once we cross 7 days, we'll just check our previous start and then increment it by 1. Again this week we'll start with that particular start. Okay, so here let's dry run it. Okay, we will start with start equal to 0. That means on day 1 I will basically keep a money equal to 0 plus 1. On day 2 we'll keep a money equal to 1 plus 1, which is 2. On day 3 we'll keep a money equal to 2 plus 1, which is 3, and so on and so forth. Okay, so we should also identify how many weeks we have. Okay, we know that every week contains 7 days, right? That means if n is 20, then the total number of weeks we have is basically 3 weeks, right? So how can we achieve 3 weeks from 20? Okay, so every week has 7 days. So if 20 was divided by 7, if we divide 20 into 3 parts, okay, 3 equal parts, that means it has 2 equal parts, and there will be one part which does not contain 7 days. So we'll basically add plus 1 to it. Okay, we'll do integer division and then add plus 1 to it. Okay, Yeah, so total it will have these many weeks. We have to go all the way up to these many weeks. Okay, so yeah, so let's jump back to the example which I have written, sample code which I have written. Okay, so we will start with 0 based weeks, even though this, let's say we have 21. Okay, that means our output will basically say it has 3 weeks, right? 7 divided by 21 divided by 7 will be 3, 3 plus 1 4. This will give us 4 weeks, but ideally we are starting with 0 based indexing of for our weeks, so we'll go all the way up to these many weeks. Okay, as you can see, I have defined weeks equal to n divided by 7 plus 1. That means we have to go all the way up to these many weeks. Okay, and then I have defined start equal to 0. We know that every week we have to start with some start, right? Some initial money, right? So initially it is 0, so I have defined initial start equal to 0, and we know we have to run this algorithm for these many weeks, right? Which is exactly less than 1 than this calculated value. So weeks will be, initially week will be 0, and we'll go all the way up to the total weeks we have, and then we'll increment it one by one. So every time we'll have the initial money equal to the start of this week, and then we'll just basically increment one money by 1 rupee every time, and then we'll add it to our total. Okay, so we know that we have total 7 days in our week. Okay, so yeah, so we should also keep track of how many days we have been crossed so far. Okay, so if you see, the first week has 7 days, so if I am at here, I am at the 8th day. Okay, so we should somehow identify at what week, at what day I am, right? So it is basically the weeks we have crossed plus the day I am. Okay, so this is what I am. So in the start of the every week is basically the weeks we have crossed plus 1. Okay, assume that we have crossed 2 weeks, then the start of my new week will be the weeks we have crossed times 7 plus 1. Okay, so initially I am at the 0th week. Okay, so 0th week times 7 plus 1. Okay, so that would be my start. Okay, I'm at this start. Okay, so this is day 1, this is day 2, day 3, day 4, and so on and so forth. Okay, so I'm at the 0th week, so the week at which I am currently times the 7 days plus 1, that will give me the current day I am currently standing at. Okay, and I have to, each week contains 7 days, so from that date we have to go all the way up to 7, and there is a possibility that we might also exceed n, so we should also keep track whether we are exceeding the current n or not, and then we should, every time we have to increment the money and then add it to our total. And once we have completed a single week, that means our start should increase, right? So previously our start was at 0, now our start will be at 1, and then we have, and then again this algorithm will keep on running. Okay, so as you can see, this is, we are just iterating from all the way from 1 to all the way up to n. So the time complexity here would be order of n. Yeah, since the constraints are also in lesser magnitude, so this will actually work. Let's try to submit this problem. As you can see, this is pretty efficient solution. Is that most of the people are not subscribing to my coding channel but still consuming my videos. I highly recommend you to subscribe so that you won't miss the content I am posting on daily basis. Thank you.